Hi friends, we shall work out one final problem with respect to the computation of the joint CDF from the joint PDF. The problem statement goes like this. The bivariate PDF is given as fxy of x comma y is equal to 1 for 0 less than x comma y less than 1 and 0 otherwise. So obtain its joint CDF and marginal density PDFs and comment on the results obtained. So based upon the given problem, this is the graph of the given joint PDF. It is equal to 1 for 0 less than x comma y less than 1. It is equal to 1 for 0 less than x comma y less than 1. So the area is a rectangular area. So x, y. Okay. So the giant CDF is given by the integral of the giant PDF. So fxy of x comma y is equal to integral minus infinity to y integral minus infinity to x fxy of x comma y dx dy. Now, as per the definition, for x less than 0 and y less than 0, the giant PDF is 0. So that's why since giant PDF is 0 for x less than 0, y less than 0, the integral of 0 is also equal to 0. So that's why obviously it follows that for x and y both less than 0, the CDF is also equal to 0 because the giant PDF is equal to 0 and integral 0 is 0. The double integral 0 is also equal to 0. Now we have to evaluate this is case 1. I have to evaluate the CDF for different cases. For x varying and y constant, and for y varying and x constant, and other such values which we are going to do now. Now let us case the second case as 0 less than x less than 1. So 0 less than x less than 1 and 0 less than y less than 1. It is varying along x and it is varying along y. So in that case, fxy of x comma y is given by integral 0 to y integral 0 to x fxy of x comma y dx dy. So it is equal to substitute the values. So integral 0 to y integral 0 to x fxy of x comma y is given by 1, where it is given in the definition. It is equal to 1 dx dy. Now substitute the lower and the upper limits. I get x limits 0 to 1 into y limit 0 to 1. So I get this becomes x limits x with limit 0 to y and y with limits 0 to x. You must be a little bit careful here. So this becomes repeat it, y minus 0 into x minus 0, or this becomes yx, which is equal to xy. This becomes xy. This becomes xy. Okay, that fellow had made a mistake, printing mistake, so that's why I have corrected it here. Okay. So this is the story for both x and y varying between 0 and 1. Next, we shall go to case 3. This is for 0 less than x less than 1 and y greater than 1. So this becomes into fxy of x comma y. In this case is equal to integral 0 to 1 integral 0 to x fxy of x comma y dx dy. So this is equal to integral 0 to 1 integral 0 to x 1 dx dy, which is equal to y limit 0 to 1 x with limit 0 to x. So I get 1 into x equal to x. Next, how we arrange it? This follows from our double integral concept which we would have studied in M1, M2, right? In first and second semester. So that those concepts you need to remember and use it here. Case 4 is the x is greater than 1 and y is ranging between 0 and 1. So in this case, I have fxy of x comma y is equal to integral 0 to y integral 1 fxy of x comma y into dx dy. This is equal to integral 0 to y integral 0 to 1 fxy of x comma y is equal to 1. So 1 dx dy. This gives me y limit 0 to 1 into x limit 0 to 1, which is equal to y into 1, which is equal to y. Y minus 0 is y, 1 minus 0 is 1. So y into 1 is y. Finally, for case 5, for both x greater than 1 and y greater than 1, the CDF will always be equal to 1 because the unit square is always included in the integral of the evaluation of the CDF formula. So that's why fxy of x comma y is always given by 0 for x comma y less than 0, xy for 0 less than x comma y less than 1. It is equal to x for 0 less than x less than 1 and y greater than 1, and it is equal to y for 0 less than y less than 1 and x greater than 1, and it is equal to 1 for both x comma y greater than 1. Next, coming to the marginal PDFs. So marginal PDF of x, that is fx of x, is given by integral minus infinity to plus infinity fxy of x comma y dy. So it is equal to integral 0 to 1, because y ranges from 0 to 1. This value of the PDF is 1. So integral 0 to 1 dy. So I get y limit 0 to 1, 1 minus 0 equal to 1 for 0 less than x less than 1. Similarly, marginal PDF of y is fy of y equal to integral minus infinity to plus infinity fxy of x comma y dx. fxy of x comma y is given by 1 as per the problem definition. X ranges from 0 to 1. So integral 0 to 1 dx. Integral dx is x with limit 0 to 1, or 1 minus 0 equal to 1. So I should, now I should comment on the result as per the given problem demand. Multiply the two marginal PDFs. So fx of x into fy of y is equal to this one into this one, which is equal to 1 for both 0 less than x comma y less than 1 and 0 otherwise. But by definition, fxy of x comma y is also equal to 1 for 0 less than x comma y less than 1. So I infer that the given giant PDF fxy of x comma y is exactly equal to the product of its two marginal PDFs. So I infer that since fxy of x comma y is equal to fx of x into fy of y, hence it is going to tell me that both x and y are independent random variables. Suppose if fx of x into fy of y was not equal to fxy of x comma y, then it would have been the inference that x and y would have been dependent. But in this present problem, since fxy of x comma y is equal to the product of fx of x and fy of y, that's why the both random variables x and y are independent. That is, the bivariate random variables capital X and Y are independent random variables in this case. This is the comment and the inference that we draw from the given problem. Thank you.